Hi patrons, it's Johannes from Noisepod and Saint Pin Mastering. Today I'm uploading an alpha build of a really cool plugin that will help you be the loudest kid on streaming services. Not really, but anyway, it may help you. May help you get your music played back a little louder, and then it should have, if you weren't aware of what this meter will help you with. It's a bit complex, but I will try to make it as simple, or explain it as simple and straightforward as possible. But you know me, I talk a lot. We'll see how that goes. It looks like this. I haven't done anything with the graphics because I don't know if I'm gonna do that either. I think this tool works without a lot of mushy graphic stuff. We just want some numbers, so it doesn't matter how it looks. So this meter shows you when the gate kicks in while playing back music, and the gate is it's the gate in the LUFS system. There are actually two gates. One gate that will gate everything that is below 70 decibels full scale, and that is a set mark that everything below that is considered silence. And what the gate does is that it takes away everything below the gate from the integrated calculation. So if you have a track with a lot of silent parts, you may lose loudness, so to speak, by having music or information below the threshold. And you probably don't have useful information below minus 70 decibel full scale, but there's another gate that will kick in as soon as the momentary value goes below minus 10 decibels or loudness units below the integrated value. That won't be calculated into the integrated value as well. And that happens far more often than the minus 70 decibel full scale threshold thing. So this started with a friend of mine who's a mastering engineer located in Denmark. His name is Sigurdur. He posted two pictures of a waveform. One that was obviously more compressed and one that was more dynamic. And he asked everyone in the forum, which one of these do you think will be turned down the least by the loudness normalization algorithm? And most people said that, well, the more compressed one. Of course, it's always like that. But the answer was the opposite. So the already louder track was actually turned down less than the more dynamic track. And that comes down to this gate. The reason was that a lot of, almost I think a third of the song was below the threshold. So if you just push that information above the threshold, then the silent parts got calculated into the integrated value. And by that, it was considered more dynamic and turned down less by the algorithm. This tool is meant to find those places in a track where that happens or may happen. And there are two different modes, or you can say that there are three modes, but there are two modes that will help you with this. First is one mode that will just show you how much can I gain from spending more time with this master or mix or composition, if you start to think about it earlier in the chain. So we're going to start by using that function, and it's the function that's called add noise in the plugin. So I'm going to show you how to use the plugin, and we're going to see the results. Unfortunately, you won't be able to hear anything because these are all tracks that I work with for clients, and I can't play them. They are not released yet, or at least most of them aren't. So it's a silent demo. We just want to look at the integrated values anyway, so it doesn't matter. So we're going to start by measure this first track. You can see in the intro here that it has, it starts really almost in silence and slowly build up. So I'm guessing a lot of this is gated out. It measures minus 13.8. We're going to put that number in the top box of the plugin. When we hit play, let's start with just a normal mode. In the normal mode, it's just a meter. It doesn't do anything with the audio. When you see gated and this little LED lit up, this means that this part of the song won't be added to the integrated calculation. So if we boost this part, let's do that. Just boost this part. Now, you can see that it blinks a little, but that means that all of a sudden this part will be added to the integrated value, and by that it will measure less loud because you're adding a silent part to the integrated value. Let's go back like this, and there's a couple of other places where it goes below the threshold as well. Yeah, you can see here, right? I think this passage here, a lot of this will be gated out. No, not. Yeah, there. A short part will be gated out. There's another part. Yeah, okay. So there's a couple of places in this track that will be gated out. Let's use the add noise function. This is a function just to tell you how much can I gain from altering this master or mix. So we have put in the integrated value of the track, and let's do a dry render just to get the number. As you can see, while we are rendering this track, the beginning doesn't look like it does here. It doesn't start at 0. That's because high pitch noise is added. It's a filtered noise that adds a lot of noise above 19,000 Hertz, just to fool the loudness algorithm that this is information that should be included into the integrated value. So you can't hear this noise. It's kind of a ditter noise, but very loud. All right, so it's finished, and we can see that it's the input measured minus 13.8 and the outgoing is measured minus 14.4, and we haven't changed anything yet. This is just by adding noise to the parts that was below the threshold, the gate threshold. So 0.6 decibels can be rescued, or whatever you want to call it, by changing the mix, how it's laid out, just by adding a little level to some elements in the most silent parts. This mix will be measured more than half a dB less loud, and by that not turned down as much as it would be otherwise. Okay, I hope you got that. Let's do the same thing with another track, or let's talk about the warn function. This would be good if I could demo but I can't because I don't have any material that I can use right now. So I have to explain it, and then you have to test it yourself. This function will, instead of altering the spectrum by adding some kind of weird noise to it to keep it above the threshold, it will just send out a beep when the gate is activated. So the idea with this is that you put it last in your mastering chain, and as soon as you hear that beep, then you know, okay, I need to either compress a little more, I need to use a gain automation to up those elements a little bit, or if you're doing like a mix, then you probably work in some part of the process, you're probably working with the limiter, so just to see how it sounds post mastering. So then you can put it after that limiter and see if, okay, here I need to add some elements, maybe some pad sound or sound effect or whatever, just to push it above the threshold. So that's great for that. Then you just work until the beep goes away, then you know, okay, now it's not gated anymore. So that's the warn function. Let's go back and use the add noise. Here's another track. So we do the whole process once again. Let's analyze it for the integrated value, and it's -12.4, -12.4. All right, and I have selected that and selected that. Let's render this as well. We do a dry output. So let's see how much we can gain by putting some level into the lowest parts of the song in this track. Okay, -13.2, and it was -12.4, so again it's a little more than half dB. It's actually almost a dB, 0.8 decibels louder. And this is actually, I already sent this to a client, so I probably should do something about those quiet passages, and by that I can make this almost a decibel louder on streaming platforms. Well, we'll see. It's always a bit of a, get back to a client and say, well, the first master I sent you wasn't that great. I have another one. I don't think I'm gonna do that. Let's measure another track. -13.5, -13.5. And I select that. So the great thing with this function is it's not necessarily that you should do something differently, but at least you can get a kind of a receipt of, well, okay, my decisions will make this track play back less loud than it actually could. And like in this situation, this measured -13.5, and if I alter the level of things a little bit, I can gain 0.3 decibels, and I wouldn't bother with that. It's not worth it. It's just too much work for very little. This is probably already pretty optimized. So let's do it with a loud track and see what happens. Again, let's scan it for loudness. And this is a loud thing, -8.2. Not crazy loud, but normal loud. And let's do the same thing. Render this to see if we can gain anything. I'm guessing that we won't gain much from this because already dense material often don't have any room for any improvement, and I was right. Yeah, minus 8.2. So nothing, you can't do anything to make this louder by using this method. So yeah, I don't know if I should, it's not much to say. If these buttons are in the up position, then it's just a meter, it doesn't do anything. So add noise, it adds a lot of noise. Yeah, and that will be something that I'm guessing you will ask. Why can't we use the add noise and just upload it to streaming platforms and have playback louder? Well, you actually can do that. I don't know. I certainly won't deliver things with this turned on, because my clients would just look at me like I'm crazy and ask, what have you done? So if you look at the spectrum after this, you will realize that this is not what you're supposed to deliver to a client. It's just to find out if I could alter it in a way so that I can add more loudness. It's not meant to be used. And there's another issue. Even if, say, Spotify, it will actually work. You will be played back louder on Spotify if you deliver master with this activated. But as soon as you make a video and upload it to YouTube, that what you gained on Spotify won't be work on YouTube unless you make sure that the container that you put the video and audio in, like an MP4 container, for example, that the audio is lossless. If it's not, which is most of the cases ain't, then everything above 16,000 hertz will be filtered out, and the noise that's been added won't be calculated with the integrated value because it won't be there. It will be filtered out. Plus, it will add a lot of strange artifacts while encoding or changing sample rates and stuff like that. So no, don't use it. Don't use it. Just use it to find out how much can I gain by working with this master a little longer. And the warn system, don't forget to deactivate it when you render, otherwise you will have a 440 hertz tone beeping every time the gate kicks in, and you don't want that in a master as well. So remember to declick it. And just quickly, what the different numbers in the plugin is. You don't have to use most of the numbers. The top box, it's the integrated value that you need to find out in some way, offline render or something like RX, or like you saw me using Reaper to find out the loudness value will be good. This shows the actual integrated value as the song progresses and plays, so what the integrated value is at that time. So if I hit play, let's hit reset to reset the algorithm. So this is just a calculated integrated, the ongoing calculation of the integrated value. You can find out this value that you need by playing a whole song. Reset and play a song from the beginning to the end, then you will have the integrated value as well. But that takes a lot of time, so I prefer to scan it in other ways and use and dial in the numbers in that field. Here's the momentary value as well. It's the same thing as the integrated. It's what's calculated right now. This is the difference between the integrated value and the momentary value. This is when this is minus 10 or more, or less, you can say, then the signal is below the threshold of the gate. So then this will lit up, as you can see. Let's play its beginning here, for example. So this is gated. These numbers shows what the numbers are when add noise is activated. They are not really something you need to use. They are still there I put them there for developing reasons, and I'll maybe remove them later. I don't know. I kept them just to, yeah, to have them. They may be interesting. I don't know. This button, there's some discussion if you should use the momentary value to calculate the gate or the short term. The way I read the papers about the LUFS system and how you should measure audio, I concluded that it's the momentary value that you should use. Others say that it's the short term. I'm not that great at math, so the formula that you get that shows you how the algorithm works, it doesn't tell you straight up if it's the momentary or short term. At least I couldn't read it like that. But I concluded that it must be the momentary value. But I added the button, so if you disagree or if I'm wrong, then you can just hit this button and it's corrected. So then I don't have to redo the plugin. And add noise, you know what that is by now. That's to test how much you can gain from using this information. And warn, it's the beep thing that warns you that the gate is activated. So that's it. That is a plugin that I call LuRar, which means trick in Swedish, and use it to find gated passages of your audio so that you can do something about it to get played back louder on streaming platforms. And that's it for today. I hope you like it. It's on Patreon, and I see you with the next plugin or update. Bye bye.